technologies. So when we are done with this, then I will take us back to I'll take us back to uh, introduction to common storage protocol. But right now, I want us to talk about storage network technologies. When we understand the concept here, then I will now introduce the concept. That's module 5 to us. So that's it, everybody. So we want to talk about storage network technologies. Then when we are done with it, then we'll talk about the protocols. So thank you everyone for joining the meeting. I believe your break was a refreshing one. Can I get a feedback? Okay, so we'll be discussing about classification of network storage. We'll be discussing network storage. Please, Bernard from Ghana, please mute yourself.
My business.
Thank you.
For WhatsApp. For WhatsApp. Make I send you right now. Why did? I beg. This might be bad timing, but then say unique insurance say them a line go down. You get any idea? Yeah. Okay. I will send you right now.
Please, Ghana, Bernard from Ghana, please can you mute yourself? Thank you. And to join the meeting. Okay. Okay. So yes, classification of network storage. So we'll be looking at DAS. What are the types of network storage? We introduce ourselves to DAS, traditional storage technology, SAN, network, and NAS, attached storage. So, we have been discussing, by now you all should have been used to SAN, DAS, NAS. In our way of introduction, we have been talking about DAS. I remember I discussed it with you, direct attached storage, then SAN, storage area network. So these are type of topology we have in data center environment. So further ado, or let's just go straight to the slide. So let's see. Sorry. So yes, data center storage network. So data storage has become one of the popular technologies nowadays and created a new technological trend after the emergence of the internet. So it brings the web into a data synchronic era. Now, data center storage network. We are talking about data center storage network, and I'm trying to tell you that with data storage, it's where they went through 3 stages of development. Data center storage went to 3 stages, 3 levels of the development, or 3 stages of development, and where's my annotation? Yes. tape to show what I need here. So, which are is divided into it went through three stages of let me write it out. Three stages of data center, three stages. So I can say one, that's then we talk about stand, we talk about so please take notes. Now DAS is a product of CPU-centric era and adapted to the initial development of computing industry. Now, the biggest technological difference between SAN and NAS is the way they use dedicated protocol or existing IP technology and data sharing. That's the difference between SAN and NAS. Now, the advantage of SAN is that it solves the initial problem of network bandwidth of storage issues. Then, while the advantage of NAS is versatility and data sharing capabilities. Okay, let me just put that here. Maybe we can just say, I don't want to spend much time on each line. So let me, the advantage, okay, SAN advantage. Okay, that is that for this. So let's move on. That's that for this. Let's move on. So now, want to look at the in a comprehensive value. Let's look at the advantage. I've just tried to summarize it over there. So SAN versus NAS. Now, for for SAN for SAN for let me start with NAS first. Let me start with NAS first, but I can start with any one of the two. So SAN, let me start with SAN. Now, SAN support protocol SAN SAN, that's storage area network supported protocols are these: fiber channel protocol and HCIA protocol. Now, SAN also supports raw device access suitable for traditional database access. SAN relies on application hosts to provide file access. Now, SAN also has data sharing access that requires the support of cluster software. So those cluster software is inside this application here. That's where we have our cluster software. So then high overhead on processing access conflict. It stands as the capability of processing access conflict. That's high overhead processing access conflict. Then stand as lower performance and it's also hard to support data sharing between heterogeneous platforms. So then we can also say that SAN has raw devices, data migration. Okay, raw device data migration is difficult. A raw device data migration, that's bringing one file from another equipment to this network, is kind of difficult because of the protocol initiator in between. So it's kind of complicated in a way. But for NAS, don't worry. In the next slide, I'll be showing you in details. I don't want you to have an idea of what this is all about. So for NAS, that's network attached storage. Now you can see the protocol, the communication protocol between the storage system and the host is this. Is this. That's NFS and CIFS. Now, what are we saying here is that that's the protocol, the file sharing protocol for NAS application. Now, also, NAS provides file access and suitable for file storage requirements. I said that NAS support file access and suitable for file storage requirements. Now, also, NAS is suitable for file sharing and file access application. Support heterogeneous, file sharing platform. So, like here, you all know that I've explained this before. Like on this system now, we have about 3 different applications from 3 different hosts. One can be Windows operating system. Windows OS. Now, but SAN only support one operating system, and that operating system can be Windows, because only Windows use, I'm aware of, use 532 and NTFS as a file format. So SAN doesn't support heterogeneous file sharing platform, while NAS support heterogeneous. Let me type it out for you. This is what I meant by heterogeneous. You can Google it if you are interested. Heterogeneous, my own meaning is having access from cross platform. 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 If I start with heterogeneous, we won't leave you on time. So an example of heterogeneous in computer world is, you know, having a computer designed by Harvard Packard, that's HP system. Then inside of it, the RAM can be, it supports heterogeneous because the RAM can be from Samsung, the hard drive can be from Toshiba. So, and the mouse can be from Microsoft. So, so that's what is called heterogeneous. It's not from one particular manufacturer. All parts come from different, the system supports different parts from different companies. So that's what we mean by heterogeneous. Now, this in NFS now, sorry, in NAS, that's NAS, support heterogeneous file sharing platform. And you can see three different OS. That's what heterogeneous is all about, and can communicate with your storage system. But in SAN, you only have one operating system and does not support heterogeneous. But it's very difficult to migrate data from here to another device. It's very difficult. It's very complicated. I told you earlier on. So let's move on. If I should be spending time explaining in this line, I'll be spending more time. I won't cover more. But I need to move fast. So yeah, here's a table. Here's a table showing the comparison of DAS, NAS, and SAN. So let's look at it together. Look at the context, storage system architecture for data transmission and protocol. DAS use CASI, FC, and ATA. So DAS is for direct attached storage. This is what they use. Please take note. What is the communication protocol for data transmission for DAS? That's CASI, fiber channel, or ATA. Then for NAS, that's network attached storage, we have TCP, that's transmission control protocol and internet protocol. And for SAN, we have FC. We have FC, but in SAN, sorry, permit me to chip in my own idea here. In SAN network, TCP/IP2 can also be implemented. But for this material, well, we can go by this, but in storage area network, TCP/IP2 can also be introduced here. And also, in fact, I will even say even in NAS technology, FC, I think maybe there's a mixed up here, but I don't know. I cannot question this material. I can't question this material, I'm sorry. But in NAS architecture, FC, it supports FC and FCOE and TCP/IP. They are all supported in NAS. Then in STAN too, STAN supports FC, FCOE, and TCP/IP. So, but for the sake of the lecture, you can continue like this: TCP/IP, TCP/IP. So then, and fiber channel. Please mute yourself. Thank you. Then, data transfer objects. What are the data transfer objects? I gave you a list the other time that you guys should take notes. Please, 3 types of file that are stored in your storage systems. We have file, object, and block. These are the 3 types of file that are found in your storage system or storage server, in Huawei storage server or your storage server in your data center. So each one has its own attributes. Each one has its own attribute. So please just take note of this 3 and you can read more on it in your notes. It is your notes. So let's continue. Let's continue. Now, data transfer object. Okay, for DAS, it is block. It is block. Then for NAS, it is file. Then for SAN, it is block. Then there's one that's supposed to be here that is not listed there. That is a distributed storage network, DSN. That one supports objects. So, but that one, DSN is used for cloud service. It's used for cloud service, and Google uses it. Your information on Google is object, not block, not file. It's object. Don't worry, as the class continues, you will understand what I mean. Then, using standard file sharing protocol. Does it have a standard sharing protocol? No. Then, for NAS, yes, there's a standard file sharing protocol. That's NFS and CIFS. So, then for SAN, no. So, because these 2 are using CASI. Let me write it out. You see the reason why I cannot rush this slide. There's a need for us to take our time to explain. And if there is more CASI, so this one is ICASI. Who is that? Kelechi Ikechi, please mute yourself. And not just that, please put your country. Look at your participants. You will see the way it goes. Mr. Adekunle, please, can you add country to your country? Thank you for joining. Kelechi, if you can hear me, mute yourself and add country to your name. Ebenezer Oduro, please put your country. Ebenezer Oduro, thank you. Odun Musu Adeshola, please your country. Kelechi, your country. Roland, your country. Suzanne from Iraq, your country. It's very important. Thank you. Rogrido Zeno, I need your country against your name. Odumosu, your country. Thank you, everyone. Mr. Adekunle, your country. Now, while we are going on, why that is going on? So now, for Skazi, yeah, you all can see that this course is getting more interesting because I had to include some information on the slide. which is very true. So you all can follow. This is HCIA, is a communication protocol that happens in DAS and SAN. HCIA is initiator is needed here, while NFS and CIFS is needed here to mount. So can someone try this? Tell me the difference between SCIA and HCIA. Anyone want to try? Raise up your hand quickly. Anyone want to try? 1 minute. Anyone want to try? Just raise up your hand. You want to try? Okay. Okay. Ahmed Quadri from Pakistan. Thank you. You want to try?
Yes, I want to try.
Okay.
Yes, SCSI is a small component serial interface which is directly attached with the host to host, one server to storage. It does. And iSCSI is an internet small component serial interface which is normally connected with the switches. It can be Ethernet switch or fiber switch.
Okay. Okay. Thank you for trying. Thank you. You got it right. Thank you.
Welcome, sir.
Yes, thank you. Roland, please, can you put your country? Thank you. Roland, if you can hear me, put your country. But let's when you raise up your hand, I won't attend to you. So thank you all for joining the class. So now, okay, now let me quickly round this up. Now, central management, not exactly. Then for NAS, yes, there's central management mechanism. Now, for central management, for SAN, requires management tools. Then increase server efficiency, no for that. NAS, yes. SAN, yes. Disaster tolerance is very low for DAS, is high for NAS, and high dedicated solution for SAN. So let's move on. Let's move on. Okay. So comparison of DAS, NAS, and SAN. This is the continuation. Okay. Suitable clients, that's SME servers, just a bunch of disks. SME monitoring broadcasting. SME means small medium enterprise servers use this and just a bunch of disks. Then for NAS, there is SME and monitoring broadcasting. Then for SAN, we have large enterprise data centers that use this. Okay. So application environment, local area network, low file sharing level, independent operating platform, yes, which is true, and less server management. For NAS, local area network, high file sharing level, high demand in heterogeneous storage format, medium. Then for SAN, for SAN, fiber channel storage network, complex network environment, high file sharing level, heterogeneous operating system platform. Hello, everyone. You need to look at this one. You know, I showed you some minutes ago. Look at it. Heterogeneous operating system. High number of servers. Capacity expansion capabilities low, medium, high. Okay, so that is that for comparison of DAS, NAS, and SAN. Now, have a look at the classification of network storages. So we need to look at DAS, how DAS came to be, and how does it operate? How is the operation of DAS? We need to look at it quickly. So DAS, that is, please take note, DAS please, anywhere you see me shading is an area of interest. So don't just overlook it. It's an area of interest. Now, this is an example of that. This is a network. So that is very suitable for small or medium-sized local area networks that has low storage capacity requirements and fewer numbers of servers. Its main advantage is that it's easy and quick, has quick implementation of storage capacity expansion with small cost of investment. A typical DAS system is made of data storage device. So, for example, enclosures holding number of hard disk drives connected directly to the computer through a host bus adapter, that's HCIA. Then don't forget either connecting through that or through JBOD, just a bunch of disks. The main characteristics of DAS is that between those 2 points, server and storage device, there is no network device like hub, switch, or router. Okay, let's see. You can see this is like a kind of like, not even a kind of like, this is bus topology. This is bus topology. Bus topology. These are your machines. Machine 1, machine 2, machine 3. Or let me do like this. One, two, three. So these are your bunch of disks. These are your bunch of disks. Disk domain. So these are your hosts. These are your hosts. go and read more on bus topology. I don't want to spend more time on this so that we can move on. So this is bus topology. So the client is connected on one single line. So there's no router, no switch, no hub managing them. So, but this type of technology, you can see let's see the highlight points here. You can see the highlight point. Storage devices are directly connected to the host. This is the host. Then no central management of data, low storage capacity utilization, poor expansion capabilities. And also with this kind of technology, there's not going to be uh, the data efficiency here is going to be very poor because the read write performance over everything is going to be very slow. I cannot recommend this type of technology for 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 an enterprise. No wonder they said that this type of system is suitable for small, medium-sized local area network. But at the same time, even if you are running a microfinance or macrofinance institution, your staff cannot get or your customer cannot get efficiency over data. Like for instance now, if you're having more than one user, if you're having more than one user on this system, okay, let's say that it's further distributed, we have more systems, we have more computer systems attached to it. System. So when all these three are trying to make requests, they will have to take turn. That's first thing, using FIFO. First in, first out. Using FIFO. I don't want to go too advanced, but for many of you that are in computer science, you know what I'm talking about. First in, first out. So, oh, sorry. So this type of technology slows the operation, business operation. So I cannot recommend it. It's not reliable. It's too slow. Each client will have to take turn or by using a waiting token to have access to file server, application server, or database server. Okay, so let me move on. Thank you. So an example, a good example of that is this on the screen. Oh. So you can see that refer to one or more storage devices that are directly connected to the server, which provides block storage service to the server. Classification of DAS based on the location of those storage device relative to the server. DAS is divided into internal DAS to external DAS. So this is DAS. This is your storage device. I showed you your storage device. This is your server. Your client passes information to the file server, and file server stores it in the storage. So then here you can see the host, which can also serve as a file server. You can see the storage is directly connected. You can see it. It's directly connected to it. So let's move on. What's that? Let's move on. So Block storage based local hard disk DAS system. So let me quickly explain this. Let me explain the DAS. So what are the connectivity modes for DAS? This is so well, connectivity mode for DAS is ATA, supports CASI, but does not support fiber channel. Does not support fiber channel, does not support this. So this technology is obsolete. This is also obsolete. So you can see that. So ID, that's Part2. These hard drives are now obsolete, and hence this machine no longer provide ID interface for this. So you can see, okay, let's move on. So what are the challenges faced by that storage? Challenges faced by that storage: poor scalability and expansion capability, which is very true. That has poor scalability and expansion capability, limited number of usable host ports, cause a limitation on number of hosts that can be connected to the storage. At the same time, limited bandwidth of DAS devices cause it to have limited input and output processing capabilities. When the read write or I/O processing requirements from the connected host is high and reaching the upper limit of the DAS devices, I/O processing capabilities, the service on the host may be affected and even will cause a chain reaction, affecting the performance of all connected hosts of the DAS storage. Due to the limited sharing capabilities of front-end host port, it caused DAS to have low resources utilization rates. In DAS system, to relocate and configure the remaining unutilized storage space is difficult, causing the formation of resource island or silo. So what am I saying in summary? These are the challenges faced by DAS storage. That's limited number of ports connected to the host, limited number of disks, distance limitation. System needs to be offline during maintenance of internal DAS, which is very true. So poor resources, poor resource sharing capability, which is true too. So to this, we have come to the end of DAS storage technology. Now let's look at SAN technology. SAN technology. So let's look at it. Now for SAN technology, we have host and storage devices that are independently expanded. You can see that you can see the host here. Sorry. That's the host. That's the host. So here you can see the host. Then this is the disk domain. I take my time to explain this thing to you so that I don't get it twisted. That is, this is your storage or disk domain, storage system. So host and storage devices can be independently expanded with the aid of this protocol. With the aid of this protocol, FC, SAN, FC, and IP SAN. SAN is the abbreviation of storage area network. So it's the dedicated network for high-speed, reliable data access and transmission between host and external storage devices or between independent storage resources. Now, SAN implements an expandable and scalable network topology connecting the servers and the storage devices, and each storage devices does not belong to a dedicated server. I'll come again. I said SAN implements an expandable and scalable network topology connecting the servers and storage devices, and these storage devices does not belong to a dedicated server. So, as it allows equal level of resource sharing between all of storage devices and hosts within the network. A complete SAN includes, what are the components? There are no rooms to type here, so you can just listen to me. Let me see if I can create a room to type this. Well, what are the components? A complete SAN includes host device that supports SAN, storage devices that support SAN, then connectivity devices used to connect all the devices in the SAN, and management software that supports SAN, and finally, services that support SAN. So, storage area network is, like I said the other time, I'm saying it again, is a dedicated high-performance network implemented between the server and the storage resources. So, it has been optimized specifically for high amount of raw data transmission. So, hence, fiber channel SAN can be seen as an expanded form of SCSI protocol in terms of long distance application. So the default protocols used by FC SAN is SCSI and fiber channel. Fiber channel is especially suitable for SAN implementation due to the fact that it is capable of transmitting large blocks of data, and is also capable of long distance transmission. The market for FC SAN is mostly centered at high-end enterprise grade storage devices implementation. So this storage implementation has high requirement for performance, redundancy, and availability. Now, for an example, components such as storage arrays and backup devices are storage devices. Storage array and backup devices are storage devices. So now, in the point listed out here, I said storage area network provides data transmission between the host and storage devices. That's in summary of what I've been saying since. It has high data transmission rate in internal network. So when we mean internal network, we can refer to as maybe an academical institution financial institutions, you know. So when you use fiber channel as medium of data transmission medium, then you should expect the high level of data transmission, then high rate of data capacity utilization. So let's move on. Let's see block storage based virtualized network-based SAN system. When we mean virtualization of network, we mean a replication of the network. So now let's see the OSI layer or the application layer of SAN. Application layer of SAN. Application layer of SAN. Let's see it. Application layer of SAN. Application layer of SAN. Okay. Okay, thank you everyone for joining. I just checked the attendance now. So thank you everyone. So okay, I'll give room for discussion later. Maybe 20 minutes to rounding up of the lecture. So I need to cover up fast. Now, for please excuse me, please let me take. I want to take this screenshot of the attendance in the class. So please hold on for me 1 minute. Let me take this screenshot. It's very important. I take it. So for picture reference, it will interest you to take screenshots of yourself so that in case you have a claim to claim later in the future, you can always refer me to this. So thank you. If you feel like screenshotting, good. It's an evidence. But if you are screenshotting, if you are screenshotting your participation and you are not duly registered, well, you are just enjoying the course because you will not write the exam. You can take the class like we are having it right now. And this exam is designed for the stay-at-home policy, the global pandemic affecting the world right now. So in a way of giving back to the society, now Huawei has come up with this program. So the exam for we have 11 Huawei professional certification courses, which are internationally recognized. So storage is one of them, and I'm your instructor for this course. Then if you want to stay certified with what you have learned, you have to write an exam. And when you pass the exam, you have HCIA in storage. And I also advise you to take HCIA in routing and switching. Now, so if you partake in this course and you are not duly registered, then you are saying that you are not qualified for the free exam voucher. Please, I'm taking my time to make myself clear because I'm not a liar. When I place the information on the social media link and you got it, you are not funny enough. Nigerians are funny when it talks about free things, and in a way they will sneak in money. We are not sneaking in money. All we want you to do is just your participation and you get certified. This is just a platter of goods. I've never seen it like that before. So in a way, maximize this opportunity, get duly registered, pay for the course, have 90% of your attendance, then you are qualified for the free exam voucher. Now, for those that is not interested in the free exam voucher, why not? You can have the class, enjoy the class, then you can, if you feel like taking the exam, you can walk into the center, publishing. I can show you the link. I can give you the link. walk in, they will register you for $200. I think is it $200 or $300? Why not? If you are buoyant enough, you can go there, then they will sign you up and you write the exam. So, but if you want to enjoy the free exam voucher, then you go through the process. I've already shown you the process on the WhatsApp group. So sorry for that digression. Let's come back to the class. Thank you. Now, block storage-based virtualized network disk SAN system. By now, I'm not going to be giving us the details of SAN. By now, I expect you to already know what SAN is all about because I'm very slow and patient enough to guide you through. But for place of doubt, storage area network. Now, this is the application, or let me say, is it the OSI layer or the layer? The layer, I would say the layer for virtualized network big SAN. So we have the app, we have the OSI application program interface, we have the internal file system, we have the SCSI initiator. So when, okay, so we have your disk domain here. We have your disk. So this your fiber channel link comes to your HCIA. I told you that I won't be giving you the meaning of HCIA, but for the sake of that, let me give it to you now for the last time. HCIA is host bus adapter. It is a converter. It will convert your FC packet to SCSI command. SCSI command for both the host and the system, your system domain or your system storage, or your controller. Sorry, your controller, which is the initiator, your host is the target, to understand themselves using a SCSI encapsulation. Don't worry, I'm beginning to sound professional, but there's no time we won't, because we have left the shore of the ocean. We are now at the center of the ocean. So it will take a strong mind to absorb this. So I need you to open your mind, and I promise you that I'll break it down to your level. But while I'm trying to break it down to, we need to also remember that there is still a lot to cover. So I might not be having time to always repeat something that I've already discussed. So thank you. Now, you all can see it. App, this is an application, this is an OS API, internal file system, and SCSI initiator. Now, SAN provides block storage similar to DAS. Now, but also has the advantage of remote connection. DAS does not have remote connection, but SAN has remote connection. You can connect to your storage system remotely. It's not a must, it must be with you in the same office. DAS, your server must be with you in the same room, the same office. But with SAN, you can be your storage system can be in other office, that your other office or store, what you made as data room. You can stay there while you can be in your office and everyone can be in their offices spooling. You're dumping their data into the data room. So SAN support that technology. Then in computer storage, a logic unit number called LUMP. You need to understand this one too. LUMP. That's logical. Please take note of this unit number. Please just take note of that. Take note of this. You need to understand that the concept of our data is circled around this. This is the breaking down of data into units in your storage. Don't worry, in time we will see it. In our storage, in our multiple drives, it's broken down into bits, and that bit is called NUM. LUN. So please, let's move on. So now, I said that in computer storage, a logic unit number is a number used to identify a logic unit. the logical unit number is used to identify a logical unit, and which is a device addressed by the SCSI protocol or storage area network protocol, which encapsulates SCSI, such as fiber channel or HCIA. So when data is being exchanged from here, this is host, sorry. I'm doing everything possible to jump this, but I can't. I'm sorry. I wish I can jump it, but I can't. This is your host. Your host can also liken to as client. So I don't want you to get confused. When I am saying host, I mean client. So I have the next 5 minutes to round up this course, so I need to maximize the time. So host or client. So you all understand that. So this is your host or client here. So then, like as seen here, this SCSI initiator, your host generates a request. Your host generates a request from app, OSI app, and internal file system. All of them are encapsulated as SCSI. Now, for your storage system to understand what the client or host is talking about, then there's going to be a card there, because your system, your host does not have a space for fiber channel. So there's a card that allows you to have access to fiber channel. That is HP card. What HP card does is that it converts, it transmits, or interprets your SCSI command in a way that fiber channel can also carry that same information to your disk controller. Your this controller or your controller, which is your initiator. So your controller or initiator now breaks it down into the language your storage system will understand, and will allow you to store your data. You can see SCSI target. You can see it. SCSI target, host bus adapter, ATA, SCSI, block storage interface, then down. Then we have SCSI initiator. SCSI initiator can only be achieved after HBA has encapsulated the data for command for your controller enclosure, because you cannot save the host cannot save directly to the system domain. No, you cannot save directly. You can't save directly. You cannot save directly. You need to pass through the controller. Then the controller now further breaks your data down into bits for your storage, for your data. Then onward pass it to your disk domain. So that's that. Please go and read more on this, on SCSI initiator. Go and read more on SCSI initiator. You understand this better. Thank you. Let's continue. I've spent more time on this one. So let's look at FC SAN and IP SAN. Okay. So you can see the architecture for FC SAN and IP. So what is IP SAN? IP SAN uses TCP IP protocol. Are you with me? Uses TCP IP protocol to communicate between the host and there's an intermediary in between, which could be your switch, then your storage, the device. Now I'm going to be explaining in details for you all to understand what I'm saying. For you all to understand what I'm saying, let me explain in details. Okay. 1 minute, please. Please, if you are joining this class for the first time, please, I will need your attention immediately after this class so that you don't miss the opportunity. Thank you. So after this class, I will ask you just raise up your hand. So in intermediary, I'm taking screenshots of the attendance. So we will compare it with what you're having in your physical attendance. So thank you. Now for some of you that used to sneak in into the class and sneak out, it's not your advantage. So do everything possible to stay behind and enjoy the lecture. Let me continue. Now, FC SAN and IP SAN. Now, we want to see the difference between FC SAN and IP SAN. Now, I said I mean IP SAN uses TCP/IP as the base level transmission protocol, and it is a storage area network architecture that uses Ethernet as the transmission medium. It uses Ethernet as the transmission medium. But now we all understand what Ethernet is all about. So going to that is going to slow us down. So let's move on. Now, default protocol for IP SAN is HCIA. My friend from Pakistan has helped us out. Ahmed from Pakistan has helped us out what the difference between SCSI and HCIA. So, and if by now you cannot pronounce SCSI or HCIA, it is not a crime, it is not a sin. Because when I was having this lecture too, I was once in your shoe. I could not pronounce it SCSI and HCIA, but now I can pronounce it very well. So now the default protocol for IP SAN is HCIA, not SCSI. There's a two different thing. So now, which defines, okay, what is HCIA? Defines the encapsulation of SCSI commands. So the encapsulation of SCSI commands is being transferred this is being encapsulated. I want to show you something. I'll delete it now. You can see HCIA here. Now, this is being encapsulated. Encapsulated. You know, for many of us, might be wondering what do I mean by encapsulation? It took me time as a computer science student to understand what encapsulation is all about. So, and I understand because I've been there before, I understand your plight. So I'm going to do my best to break it down. Encapsulation is just like capsule. Capsule. Many of us have seen drugs before, or different type of drugs. So we've seen some that are very naked, that when you swallow it, it's very bitter. Now, because of that, science went further to put that same drug inside something that looks like a rubber, small rubber. It's called capsule. So capsule means that drug that is bitter has been encapsulated. So when you are swallowing it, you don't feel the urge, the hurt, or the bitterness on your throat or your tongue. So yeah, I've just broken down for you, for many of us. So encapsulation is the same word we are using here, encapsulation. of SCSI. Please, I want you to, I thought I changed the color of this thing now. Oh, yeah. I better leave this one then. Let me delete it. So our time is fast spending. So now, so encapsulation. Now this encapsulation, so we all can see it. Now, well, by the time this wants to communicate from the host, it becomes SCSI. And SCSI, the difference between SCSI and SCSI is internet. That I means internet. So first thing first, SCSI, the SCSI protocol in IP SAN, in the host. By the time it wants to communicate out remotely, it has to go to, because it is going through your HBA card. HBA card now encapsulates SCSI commands and send it through TCP IP. So that process is called SCSI. SCSI command sent through the internet, sent through TCP IP. It's called SCSI. I believe I've done justice to that explanation. So then, so like I said, I've tried to summarize that the default networking method are for IP SAN. The default networking methods are direct connection. The host and storage devices are directly connected via network card, TOE. That's a TOE. That's a TCP offload engine card, or SCSI, or HCIA card. Any of these can work for IP SAN. We have TOE, that's TCP offload engine, that's that's TOE. So we also have, it's a card anyway, it's a card. And we also have SCSI, then we also have HDA card. So then this type of connection are simple, economical, but will be difficult to share storage resources in scenarios where there are large numbers of hosts. When you are having a large numbers of hosts, you will be having some kind of technical challenge. So single switching. Okay, another point here is single switching. Host and storage devices are connected directly. Host and storage devices are connected through a single Ethernet switch, where the connection on the ends of the host and storage are still using Ethernet network cards. So that's that for this one. Let's move on. So for DAS, you can see that it's using SCSI protocol. And an example of DAS is this. You can see it's directly connected to the storage. You can see it's directly connected to storage. So for FC SAN, you can see the donor system. You can see fiber channel switch 1, fiber channel switch 2. This system is designed to eliminate single point of failure and for load balancing. So any of it can continue operation. If one link is broken, another link take over. So you all can see it. So same thing for IP SAN. So the communication file sharing protocol for this one is SCSI. You all can see it. So component of a SAN system. Let's look at component of a SAN system. So that's it. Component of a SAN system. Component of a SAN system. Application server. transmission network, and storage devices. So these are application servers. They are connected through Wanayo switch. That's switch. It could be FOE. It could be FOE. It could be external. So used to carry your data. Then this is your storage system. So now, like I said, even like I said, so your SCSI, your iSCSI protocol using HCIA card transmits data over the FOE, sorry, then send it. When it gets to the storage system, it hits the controller first. So when it hits the controller first, the controller now using the controller, any of the controller, maybe A or B, process the data. The CPU process it, pass it to the RAM. You remember I discussed it with you earlier on. Then the RAM now pass it to the disk enclosure. These are your array of disks. Disk enclosure. You can see it. You can see it. You can see it. So hence, the difference in storage devices lies at the front end network interface, IP or FC, and the back end device disk channels, SAT or fiber channel based on different combination of the front end and back end technologies. It forms four main storage device architecture, which are IP plus SAS, IP plus FC, FC plus SAS, and FC plus FC. Commonly, FC SAN refers to the storage device that connects to the server using FC protocols through the FC network interface, while IP SAN refers to the storage device that connects to the server using iSCSI protocol through IP network interface. I'll come again. I said FC SAN refers to storage device that connects to server using FC protocols through the FC network interface, while IP SAN refers to the storage device that connects to the server using iSCSI, using iSCSI protocol through IP network interface. So let's move on. Let's move on. Let's look at the initiator. How does it look like? What have I been saying since? Let's look at what I've been saying since. Discuss the initiator. NIC. Can somebody help us? What is NIC? Raise your hand if you know. NIC. Please raise your hand if you know what is NIC. You don't have to Google. Please give me 1 good minute. Let me see. Hold on, please. Okay. With the performance of my battery now, so let me off the generator. I'm on generator. So I'm having some kind of feedback from the generator. So I need to turn it. Just 1 minute. Keep your hands raising up. Just less than a minute, I'm back. Okay. Yes, I'm back. So, Suzanne, can we have you? Can we have you? What did you say? Okay, thank you very much, everyone. Yes, thank you. Thank you very much. Yes. She has answered it. Everybody put your hands down. We only need one response, and thank you for contributing. So, let's continue. Now, I've been talking about SCSI initiator. So we are looking at, okay, what is the mode of communication when you're from your host to your storage devices? What are the communication medium? So now, like my friend from Iraq said, network interface card. I didn't even know it's even on the screen. I didn't even know it's on the screen. So yes, it's for many of you that doesn't know. This is so an example of network interface card is on your computer, your laptop, your workstation in the office, where you plugged in your RJ45, your internet cable in your office. That interface is called network interface card. There's a card inside the hardware in your system. So that's network interface card. So now talking about SAN, that storage area network, NIC is required. We need NIC to communicate with our storage device. So if you don't have, if you have a server, it's not even possible for you to have a server without a NIC card. Without an NIC card, you cannot transmit IP SAN. You cannot transmit packets. You cannot transmit packets of your data from your server from your host, to the storage. So this is your host. Anytime you are seeing a box like this, just know that we are talking about host. And don't forget I said your host can be host or client. Don't mistake it, host or client. So it depends on how you understand it. But I prefer host, but if you can just get to see questions about it, don't get it twisted. So now let's continue. Now, initiator software completes the HCIA packet to TCP/IP packet conversion and requires host CPU resources for this process. So you can see it. So then we will require well, you can't just plug it directly. Okay. From what we have here, don't mistake this as direct attached storage because you are seeing one single lane. Because you are seeing one single link does not mean that this is a direct attached storage. Please. So this is internal bus. This is internal. The red sign is the internal bus. Benny's waste phone. Please, can you rename yourself? Beniwe's phone, please rename yourself and your country. Thank you. Latif, Karl Latif, your country is required. Odumosu, Adeshola, please, I have the host right. Don't let me do otherwise. I have the right to remove a member from this meeting, and I won't want to do that. Please, everybody should rename yourself well and put in your country. It's very, very important. Thank you. Huawei is monitoring this section, so I won't want us to do what will go against the meeting. Thank you very much. So let's continue. I don't want to even be distracted, so please just do as said. Thank you. Then back to the class. So host devices such as servers and workstation connect to Ethernet switches using. I knew there's going to be switch here, but it's just that I knew there's, but having a single link here, but it's just showing us the procedure of how your host is being connected to your storage device. It's just showing us how your so that's why we're having a single link. But this single link does not mean that that's how it should be. So we can have this NIC is behind your workstation. It is integrated inside your workstation. So we are just showing you a way of explanation. It's just a way of explanation to bring it out for you to see. Look at it's just a way of explanation. It's residing behind the system. This card there. So that's why we're having red link. If you can see, it's a red link. And this red link is talking about internal bus. You can see it here, internal bus. Then talking about the Ethernet. So inside this IPs and this cloud, we are having a Ethernet switch. We can have FC switch, fiber channel switch, or fiber channel over Ethernet, or TCP/IP. So Ethernet switch is here. So please don't say because you are seeing a single link here is direct attached storage. No, it's not direct attached storage. So direct attached storage does not support IP SAN. So that's that. Then, having said this, let's move on. We've dwelled so much. We have less than 30 minutes to end the section. So let's see if we can cover more. Okay. Now, TOE. I give a illustration. That's I want to get it right. I don't want to mix it. Why? I don't want to mix it. Please hold on, please, for 1 minute. Let me see. I used the word TCP here, somewhere here. I used it somewhere. The terminologies are interwoven, so I have so many on my head, so I don't want to misinterpret the class, so we don't confuse us. I don't further confuse us. So if I didn't see it right now, then I will get it across later. So let's continue. Okay, let's continue. Don't worry. Let's continue. We are still in order. So TOE NIC handles the TCP/IP protocol level functions, while the host process the HCIA protocol level function. Hence, by using TOE NIC allows a high increase in data transmission rate. Now, compared to the method where only software is used, this method greatly reduces the host operation overhead and does not increase the cost of building the network greatly, which serves as a configuration solution that offers good comparison for performance and cost. Yes, I knew it. I knew it used to be TCP offload engine. That was what I was going to. TCP/IP offload engine. Now it has come back to my mind. I knew that I knew it. TCP/IP offload engine. Please, that is what this stands for. Please take note. Take note. I took my pen to remember. So this is it. TCP/IP offload engine. So I've just told you the function. Okay. So now this is in the former. Sorry, not in the former. In the last line. In the last line, you can see we are already having just NIC card that communicate that encapsulate this encapsulate. You know, I told you it encapsulate this SCSI into iSCSI. Good. Now, in the next class, we are looking at TOE NIC plus initiator software. So I've just explained what this initiator software does. Then the toad that that is the TCP/IP offload engine is a technology that is gaining popularity in high-speed Ethernet system for the purpose of optimizing throughput. Now, TOE components are incorporated into one PCB, that printed circuit board. For many of us that did computer architecture design in computer science, you will remember this PCB. That's a printed circuit board. Please take note of all this. Please take note of it. What is printed circuit board? For many of us, is not. You have not gone out of place. When you open your any of the device, maybe your TV, maybe your phone, you open your phone. I mean, you persist your phone. There is a board inside. That board is called printed circuit board. Then in your computer, your motherboard is also PCB, printed circuit board. So let's move on. Now I said that having told that TOE NIC has gained market popularity and in high-speed Ethernet system for the purpose of optimizing throughput. So, and I also said that when I mean that's TOE, components are incorporated into one printed circuit board, such as the network interface card. So it has been incorporated inside this place for better performance. For better performance. For better performance. No, sorry. They are all referring to it for better performance. That's optimized throughput. So then in recent, so okay, okay. Now such as network interface card or host bus adapter. So it has been incorporated inside. That's TCP/IP offload engine. Is the function is an additional function on the board on this NIC. So what it does is to optimizing throughput. So when data is coming from here, it processes fast and push it to storage devices. So that's that. So okay, let me say something before I move to the next. So in recent years, the communication speed in Ethernet system has increased faster than computer processor speed. This produces an input-output bottleneck the processor, which is designed primarily for computing and not for I/O, cannot keep up with the data flowing through the network. As a result, the TCP/IP offload engine processed at the TCP/IP flow is processed at a rate that is slower than the speed of the network. So TOE has solved this problem by removing the burden. By removing the burden called offloading from the microprocessor and the I/O subsystem. So it has been integrated here to manage throughput. That's optimizing data throughput. Instead of the CPU, the computer CPU to be managing so many system resources, hardware resources, software resources, and now when it comes to after being processed, now the same server wants to process by pushing out data to the storage device. Now it's going to be slower with this technology, with this NIC. With this NIC, please follow me. With this NIC, it's going to be slower. This is solely dependent on. Sorry, this is solely dependent on. Sorry, this is solely dependent on CPU resources and can slow down throughput through. Please take note. Please take note. So this is an additional information I've just put here. So okay, we will be rounding up here. So the difference between NIC initiators plus initiator software and what is being discussed here is that SCSI comes from here. Like you see what it says here. It says initiator software completes the HCIA package to TCP/IP packet conversion and requires host CPU resource for this process. So because of this process now, the throughput is going to be slower. Because of this process, sorry, we are rounding up the lecture in the next slide. So because of this process, because of this CPU resources process, the throughput is going to be slower. Here, we're using this card. Okay. Sorry. Throughput is lower. Throughput So because of this challenge, then TOE was introduced. That's exactly what I want to say. TOE NIC was introduced. So I hope you all can get the difference now. So just you can, this is an additional information here. So you can screenshot. Because of the limitation of these CPU resources, TOE was introduced. So TOE eradicates that burden using offload engine. TCP offload engine takes care of that. So look at this. TCP IP protocol packet conversion is completed by the TOE NIC, which does not use host processing resources. Can you see it? It's not using CPU resources at all. It has its own resources. It manages its own resources. You all can see it. Take note here. Can you see it? Good. So that's how to read. So yeah, okay. Let me do my best to just try to read out. I've even explained everything in a summary. So I believe we have said. So this is where we'll be stopping the lecture today. Tomorrow we'll be discussing HCIA HBA board. HCIA HBA card. How it's been how it transmit data to. So, or let me see. We still have a long to go. So there's no point, except if I want to skip, and there's no point skipping. So we'll discuss this tomorrow. But if I can see, I want to use this many time for question and answer and everything. So we are stopping here. So thank you very much. So you have any questions?